expanded sum of product solution. So, not a particularly nice equation, so we're going to have to use De Morgan's law to try to get it down into a sum of products or a product sum. And the only thing we've been talking about are sum of products. But we can certainly implement our functions in product of sums. Stress that too terribly much. Okay, so we've got to apply De Morgan's theorem. So this is going to be A bar or B bar or C bar bar. Is that all right with everybody? C bar bar is C. Or then we're going to have, this is a new variable, so it's going to be A C bar bar ANDed with B C bar. Is that all right with everyone so far? Got to apply De Morgan's theorem again. This is going to be A bar for C bar bar, which is C. Get that right? ANDed with then B bar for C bar. Is that okay with everybody? Okay, so we can take this guy here and multiply it out, if you will. So this is going to be A bar, B bar, or A bar, C bar. That's taking this term times those. Or C, B bar, or C ANDed with C bar. What do you get when you AND a variable with its negation? 0. Is that all right? So this guy here is just 0. And then anything ORed with 0 is the anything, correct? So do you see that it's just like, we don't even have that out there. Everybody okay so far? All right. So we need to do a map here now. We could do a truth table, but the truth table doesn't help us in minimization of the function. So we'll go ahead and do a Carnot map. How many cells will we need? 8. We've got 3 variables, correct? Now, you can put this thing any way you want. You want them 2 by 4 or 4 by 2? 2 by 4. All right. How about 4 by 4? Try that again. Okay, so we'll have our A variable there, and our B and our C variable there. And of course, this is the map for our function f. We need to put our possible variables down here that the inputs can have. So 0 and 1. 0, 0 for B, 0, 1 for BC. Got to do it in a gray code, so we're going to do 1, 1, and then 1, 0. If you don't do it in a gray code, it all falls to pieces. Everybody's okay? So we're going to implement this term here. What cells give us a 1 for A bar? When is the function of 1? Okay, it's all of those. Understand? Okay, for B bar, that is these 4 cells here. Everybody still doing okay? We now have C. Wait a minute. Okay. C, I did that right. So C is going to be here and here, correct? These 4 cells. Okay so far? All right, then we've got, when we have 2 terms, we're going to fill up how many cells? 2 cells. If I had all 3 terms in a product, I'd only fill up 1 cell. So I've got A bar, B bar, so when A is a 0 and B is a 0, so that's going to light up these two guys here. We'll put a 1 in these two cells. You need to see this done even more explicitly. If you're not following, holler. All right. So what about A bar, C bar? So we want to light up all the cells with a 1 where A is a 0 and C is a 0. So that's these two guys right there. Then we need to do C and B bar. So C's a 1, C's a 1 here, and B is a 0. So that is those two there. Doing all right? Okay. What do we do with that extra one? That's a 0, correct? All right. So really a very full map. We want to do, well, in our expanded sum of products, how many terms are we going to have? We'll have 7 of them. So to implement this particular guy here, let me call that A. A, in order to make the function true, and I want to just incorporate that particular cell, that's going to be A bar, B bar, C bar. I shouldn't do A's, let's do capital A. Next one over, we'll call that B. What is the expanded term for it?
A bar, B bar, C.
Doing okay? So the only one that we're not going to have is the A, B, C bar. That is the only term that we'll not have in our expanded sum of products. Everybody fine with this? Yes? Okay. So let's do minimum sum of products. This may not be unique. Okay, there may be multiple ways that we can cover all of the ones. First, you like to cover as large a group of ones as you can that are power of 2s. Do we have 8 ones? If we had 8 ones here, our function would be what? Just 1. Okay, if we had 8 zeros, the function would be 0. It wouldn't matter what the variables are. So do we have groups of 4 ones? The answer is yes. So let's go ahead and take that guy there. What variables are changing as we go through that group? B and C. The only one that is not changing is, and in fact it's a bar. Doing all right? Well, we still have 3 ones to cover, and you always try to put them into as large a group that you can. So, see any other groups of 4? So here's a group of 4 here. And that will be what? A variable is changing, yes. C variable is changing, so we don't include it. The only variable that's not is B bar. So, B bar. Got a lonely 1 there. Can I do anything with it? Can I stick it into a larger group? Yes. Group of 2? I can stick it into a group of 4. Okay, and that group of 4 is there. So that would be, is the A variable changing? Yes. Don't include it. Is the B variable changing? Yes. Don't include it. The variable that's not changing is
C.
You can put ones with another group.
Oh, you have?
If it's like already been a part of another group.
Yes, oh yeah, absolutely. Absolutely.
So it's better to do it in a group of 4 than a group of 2, no matter how many times it's already been used?
Absolutely. Okay. Okay, so what we're going to talk about today is implementation of this thing with gates. Okay. So if I were to implement this function up here, the expanded sum of products with gates, okay, so I have inputs that are A, B, and C, correct? Those are the inputs, not the negation of them, okay? Your true inputs into this box are A, B, and C. So what do you need to do if you have to have a negation of an input? You gotta put a not gate there. You've got to invert it, okay? The true inputs are just A, B, and C. But I have to generate A bar. Okay? When we are doing lines like this, if they are a connection, we put a dot on it. If it just crosses, it's not a connection. Okay? This line is connected to this. B and C are not connected to that not gate. Too many knots going on. I need to generate B bar, and I need to generate C bar. Okay, what about this term here? How do I generate this term here? With what type of a gate? I'm generating this term here. What's the gate I need to do? An AND gate. How many inputs to it? 3. And what are those inputs?
A bar, B bar.
A bar, B bar, C bar. So I have A bar, B bar, and C bar. That's going to go into a 3-input AND gate. And so right here, this is the term A bar, B bar, C bar. All right. What's the next term I need to generate?
A bar, B bar, C.
A bar, B bar, C. So the way I do that is I need A bar, I needed B bar, and I needed C. Where do I get C from? Way the heck over here. This is my input, correct? So that comes over here. That goes to a 3-input AND gate, and this gives me A bar, B bar, and C. What else? What else do I need to do now? Am I done?
7 terms.
I got to have a total of 7 terms, correct? Everybody understand that? I'm going to have 7 of these guys. Okay. So 7 more of them. Then what do I need to do? You got to OR them together. Those individual functions or variables at this point now need to be ORed together, and so I'm going to have to take those into a 7-input OR gate, and this is going to be my F variable there. How many total gates have I used? Be careful.
8.
11 gates. What are they? The 3 NOT gates, 7 AND gates, and 1 OR gate. 11 gates. And how many separate inputs? A gazillion of them. Okay, a lot. Okay. Now, let's implement this guy. This is exactly the same function. This is our minimum sum of products solution. So to implement this, here's my A variable, my B variable, my C variable. What do I need to generate?
A bar, B bar.
Okay, I gotta generate an A bar, correct? So I'm gonna take my A, come over here, run it through a NOT gate, and here's A bar. How about B?
B bar.
I gotta generate the B bar, right? Remember, your inputs are only A, B, and C. If you need the negation, you gotta generate it. So we'll come over here, negate that, and there's B bar. Do I have to do anything with C? No. Okay, so now what do I need to do? Or those three terms together. So I'm going to have A bar, B bar, C all the way over from here. Run those just through a 3-input OR gate to give me my F function. So how many logic gates did I use? 3 of them. And how many inputs? 1, 2, 3, 4, 5, just 5 inputs. Okay. Reliability goes way, way up. And you would never, ever want to implement a function from an expanded sum of products solution. Doing okay? Now, I told you that we could certainly generate a product of some solutions, and it may or may not give you less hardware to implement the functions. Everybody doing all right with that? No, I may or may not show you how to do that. Any questions?
With the like the first gates that we did, I get the last two that we did, but the first three where we have A going to A bar.
Remember, you got a box. This is a sack, not a box. You only have 3 inputs, A, B, and C. And here's your output F. Inside the box, if you need the negation of those terms, you have to make it. And so we run it through a NOT gate.
Okay.
Right? Other questions? We've already talked about a 4-variable map. So let me just put up a map here and we'll take a look at it. So again, we have to put our progression of our input possibilities into a gray code. On the final exam, what are you going to do? Use a gray code. Let's see if you remember that far. All right, so let me put in some 1s here. I'm going to put in more 1s in a moment. Assume right now that everybody else is a 0. And we're trying to implement this. How would you do it? You're always trying to put your 1s into what? As large a group of 2, power of 2 as you can. Have a group of 16 1s? No. 8 1s? 4 1s? We got 4 1s there. Can we put them into a group? No. Okay. So now, what about this guy here? What would I do with it?
Count it twice.
I could put it into a group of 2 there, correct? And that would leave me what? This guy to cover. But I could stick it into what?
A
These guys.